Good morning, everyone. This is Crystal Javi. I'm a research scholar, and today I'm going to present my project, that is coverage and connectivity issues, to minimize the coverage and connectivity issues in wireless sensor network using grasshopper optimization based on selective activation scheme. So the overview of the work is, first of all, objective. What's the objective? Then introduction, literature survey, methodology, result and discussion, and then the references. So the main objective of this work is to maximize the coverage and ensure connectivity in wireless sensor networks. And coming to the introduction part, in wireless sensor network, small device, the sensors are the small device, small component, and but its application is broad. uh, Many useful applications are there in the wireless sensor network. And according to the structure, wireless sensor networks is a network structure, contains number of sensor nodes, and the sensor nodes are connected to a gateway, and then to the base station, and then uh, to the um, users. Okay, so this is the overall architecture of the wireless sensor network, and the main components. What are the components in what are the components in the sensor? That is, first of all, structure. That is, the node contains a sensor unit, microcontroller unit, transceiver unit, then a storing device, and then a battery. So this is a small device, and uh, capacity is a minimum level only. And then gateway, there is a gateway. So the gateway is a radio unit, interface unit, and then battery. Then communication modules means short range communication as well as medium range communication we can use. And the topology as well as that is star tree mesh like topology we can use. And the communication is long range. There is for communication model, short range, medium range, long range. It's apart according to the application. What are the application we are using? According to that, we can use this. The communication model may come. And the next one is um, characteristics. So, what are the characteristics of the overall wireless sensor networks? Is first of all, it's a device having low energy, but it can sense the information from anywhere. And then its ability to cope with node failure. If some node failure may occur, it can communicate to a nearby device, and the information, it will pass the information to the other device. So it hooked to the node failures. And then heterogeneity and homogeneity of the nodes. So it may work as a cluster head, like a heterogeneous way as well as homogeneous. So it's the main characteristics. And then the scalability to large scale of deployment. So everywhere, anywhere we can deploy, and it will be scalable to that. And also it has the ability to withstand harsh environmental conditions. And then easy to use, easily we can use. And then cross layer optimization. So these are all some of the characteristics. And the application, many applications are there. Mainly it will sense the information. So whatever information it's capturing, like in gas we can say city pollution, particle dust, and then forest fires, greenhouse management, humidity, like many applications are there. It will it will monitor the temperature level. So events like in security, if we place as a surveillance, in surveillance, if we place the sensor device, it will give vibration, then Hall effects. That is some if anybody coming means some information, there is some low vibration or some hall effect it will give. And then in smart water, pollution levels in the sea, and as well as the video camera, that is surveillance, military deployment, like many applications are there. And then next one is the smart cities. Smart city is developing new application now. So in such application, our sensor nodes are playing the main role. So wireless sensor network is also a main part. And the smart parking. Smart parking means uh, whether we can there is available places they are for parking the car or any device. So like some important applications are there. Then agriculture, precision agriculture. There is leaf temperature, irrigation systems, greenhouse effects. What are those? Like some information we can capture. And then the next one is the design constraints. So many applications are there, and there are many characteristics in wireless sensor networks, but there is some design constraints are there to get a better wireless sensor network. So for that, first of all, I have taken some of the design constraints. First one is the topology, then is the coverage and connectivity. So the overall coverage and connectivity, we concentrate on the design constraints, that is the energy efficiency, QoS, and network lifetime. So these are some of the design constraints I've taken from my research work. And then mainly the design constraint is the coverage and connectivity. So what is coverage and what is connectivity? Area covered only if each location of the area is in the sensing range of one or more active devices, sensor nodes. Then it's come under the coverage. Therefore, the point of interest, if you are selecting a area of interest, has to be occupied by at least one sensor to connect effectively. So then connectivity means, in order to convey the sense data to the base station, connectivity plays a crucial role. The sensors can be connected only if it has at least one neighboring node, then it is to be connected. So this is the overall function, but there is some drawbacks in this coverage and connectivity. So what are those, and how the previous was rectified, and where they missed, like in the next part I will discuss. So some of the related work regarding this coverage and connectivity. And in this paper, Gupta, 2016, they developed a GA, genetic algorithm based approach for this connectivity, coverage and connectivity, and they applied well in they are and the genetic algorithm, the cross chromosome representation and the fitness evaluation plays a main role. And it's mainly used for to detect the target points, so detecting gas leakages. Then limitation is suitable for target based wireless sensor methods, not for random deployment. Randomly we can't place. This is one of the drawback. And the next one is genetic. This is the next paper also concentrating on the genetic algorithm, but it's an improved version. So it will first find out the redundant or unnecessary active nodes, and discard this redundant nodes from the network. Because if we are if it is unnecessary, means it utilizes the energy. So we are in their paper, they are first find out the finding that the what are those unnecessary active nodes, and then they are eliminated. And the next advantage is full coverage of the target points, and then maintain connectivity among the active sensor nodes and base station to forward the sense data. And limitation is the network cost is high. And the next one, mm, This is artificial learning. Most of the soft computing algorithms, that is swarm intelligence behavior, is applied for this coverage and connectivity. So next one is the artificial weak learning algorithm. It's a weak learning algorithm is improved somewhat. So there may be some optima trap. So avoid such conditions. Um, this improved version is used, and it is better in coverage and connectivity. Then, but it is only for the design for deterministic deployment. Then next one is the gravitational search algorithm with social skydriver based model. So this model is um, it's a good one, and this gravitational search as well as this SST dynamically performing the best. And the advantage is much better in terms of selected active sensors, rate of uncovered area, and network lifetime. But the limitation is complex and maximum processing time. The processing time may take. And the next one is IDDT genetic algorithm, but IDDT-GA. This is it's also concentrating on the coverage with a lower number of nodes as well as minimizing overlapping area between neighboring nodes. Variable length encoding is used to construct each row. Then advantage is increase the coverage of the monitoring area. Then the limitation is mainly it is concentrating on the coverage but not ensuring the connectivity. Then power consumption also high. Power consumption is our main, but here power consumption is high. The next one is multi-hop clustering routing protocol using child genetic algorithm. So genetic algorithm is playing a major role here, but there are some drawbacks. So the so many researchers are improving the genetic algorithm to better concentrating on this coverage and connectivity issues. Here, they are performing the routing process also. So advantage is the energy dissipation. It minimizes energy dissipation, and in the genetic algorithm part, it produces invalid offsprings during mutation. So the process may get deviated, and then overall summary of the literature review. So summary is it is observed that the existing methods fails to meet problems for improving the network lifetime like coverage, overlap less connectivity, minimum coverage, so more active sensing nodes and energy consumption. So there is an alternative method is required to overcome these drawbacks. And so I am concentrating in my proposed part this coverage and connectivity issues. So the main aim is maximizing the coverage, ensuring connectivity, minimizing the coverage lag, selection of nodes with higher residual energy, and minimizing the sensor nodes. Then the return model. So first of all, want to design the model. First of all, the sensors are assumed to have linear similar initial energy. Then the nodes are randomly distributed and are static. Each sensor node has a sensing range with a limited battery capacity. No significant obstacles in the network. The sensor nodes coordinates are known. These are some of the examples. And the next one. Sorry, this is the network model, how we design the network. And then it is next one, here optimization algorithm. So objective, first of all want to um, make the objective function. So the main objective function is to maximize the coverage. Mainly it's based on the Euclidean distance, the maximizing the coverage. And the next one is ensuring connectivity. It's also based upon the equilibrium distance. So connectivity, how ensuring connectivity, what is the objective function. And then our proposed algorithm, that is grasshopper optimization algorithm. This algorithm having a mainly the behavior of grasshopper is the main thing here in this algorithm. There are two stages: larva stage and adulthood stages in their swarming behavior. What are the functions means exploration, exploitation, then target seeking. So it search the agents abruptly, then exploitation phase, it's more locally, then target seeking phase, food source seeking. So our target is to ensure connectivity, coverage and connectivity. So that's our target, and according to that, this algorithm will work. Oh, yeah. Here, the position of the grasshopper. Here, where the grasshopper is there. So grasshopper here representing our sensor nodes. So where it's moving, like how we can select. There are some behaviors, social interaction, gravity, advention is the main behaviors, and in the social interaction, there is two forces and one zone is there. So one is the comfort zone, then attraction force, then repulsion force. So according to this behaviors, the grasshopper social interaction be defined. And then next, gravity and advention. These are all also the main functions. This and so how the social interaction will happen: attraction, repulsion and comfort. So there is some criteria is there to how when the repulsion, when the comfort zone, when the attraction method. Then next one is a gravitational advention. So, how the gravitational force in the grasshopper is defined. These are all the equation for that. And the next one. In that exploration and exploitation phase, exploration stage is nothing but the adulthood stage. So it is defined like that. And then next. This is the algorithm, see the code, how it is defined. So initializing the swan, then Cmax and Cmin will also initialize, and the iteration count. So first of all, fitness evaluation. Then there is two phases there, name phase and the adulthood phase. So according to these two condition, the process of position updation is done, and then if it is reaches means terminate, otherwise repeatedly that optimization process is going on, that is updation phase is going on. After calculating the fitness position, the position is updated, like this the process will go on. This is the flow chart, the same as like the pseudo code. What are the functions are there? First, initializing the population, then fitness evaluation, then determining the name and the run states, then calculating the distance between the grasshopper, then updating the grasshopper position. If the best positions obtained so far, then we will get the coverage and connectivity. So we will stop. Otherwise, the process will repeat. So then we move on to the experimental result and discussion. There are some parameters taken: GA, IGA, and IABC for the comparisons. So point of interest means some area, 300 meter cross 300 area is chosen, and then number of nodes. Total number of nodes is 150 to 400, and then target points 40 to 80. Then sensing range of a node 40 meter, and base station location 300 150. Data packet size 40 bytes. Initial energy of a node 1 joule. Communication rate. So these are all the some of the parameters, and there is two scenarios are taken. One is sensor nodes and the target nodes are randomly placed, and then known as the grid-based network topology, and in which sensor nodes are placed in the grid crossing points and the target points are randomly placed. So and for the two scenarios, how the sensor nodes are placed, and how we are achieving the GOE, our proposed algorithm results. Then for the scenario 2, how the grid deployment is placed, and what's how the our result, coverage and connectivity. Then the performance evaluation. So active node analysis. First of all, active sensor nodes analysis. How many selected sensor nodes out of 300, and for the number of charger points. And then energy consumption analysis, how the our energy consumption for our OASA algorithm, how the energy consumption. And then the connectivity analysis. So first, node time, number of sensor nodes for the number of sensor nodes, the first node time to calculate the connectivity analysis. And then next one is the network lifetime. So for number of rounds, how many alive nodes are there? And then the throughput analysis. So throughput, how the transmission process, and how the we are achieved. And then the residual energy analysis. So for number of rounds, how what is the residual energy? And then finally the convergence analysis. So here we have used the optimization algorithm, so convergence analysis. And the future plan of the work is focusing on delivering the data without delay to enhance service quality. Secondly, to concentrate on trust and privacy for microphone application. Then that furthermore, the other evolutionary algorithms are there. So we can concentrate on those evolutionary algorithms, and these are other references. Thank you.